Okay, here we got another question, but this time around we're going to also get the current equation. Okay, I'm going just to put them there so that you can see. We're going to solve for the current also. So let's start with loop 1. This is loop 1. It's actually loop 1, not loop 2. So this one is loop 1. This one is loop 2. Okay, so we're going to solve for the sum of voltage, sum of the current. So we're going to mention here Kirchhoff law of loop 1. Okay, and then we're going to solve here for loop 2, and here we're going to solve for the current. Okay, just to make it clear. So what can you do? What will you do here? Okay, so the source, the input source, it's E. Okay, so it's gonna be E. Okay, if I have to represent it, it's gonna be VE equal VE in T domain will be equal. So it's gonna be the sum of the voltage across the resistor plus, so it's gonna go like this, the sum of the voltage across the capacitor and the sum of the voltage across the inductor. If you have to solve for this equation, so it's gonna be VR1 of T plus VC1 of T plus VL1 of T. This is what you're gonna get on loop 1. And then if you go to loop 2, it's gonna be the voltage across the capacitor will be equal to the voltage across the resistor. This is what you're gonna get on loop 2. So it's gonna be VR2 of T equal to VC1 of T. Okay, now let's talk about the current. And what you see here, this is where we have the current is gonna go across the capacitor, so it's gonna be IC. Okay, so IC is the voltage that's gonna go across the capacitor, and the direction we actually don't know. So what we're gonna get here for the current across the capacitor, so the current across the capacitor, okay, so if we have to get the current across the capacitor, it will be equal to the sum of the current, because all the current are going out, so meaning that the capacitor current is gonna be this way. So it's gonna be like the sum, the sum and the subtraction of the second current. So it's gonna be something like this. If I have to give you the equation, it's gonna be the first current, just let me just make myself clear. Okay, it's gonna be the first current minus the second current. This is what you're gonna get for this equation in terms of current. So you're going to subtract these two in order to get the current for across the capacitor. Okay, you can even see the error that we got. So then from here you'll take this equation further on, and then you can solve, okay, for the equation that you get. And we can even just instead of calling this one as VE, we can just call it E. Then with this equation you can solve this circuit easily, the way we see that. So this is what I was trying to give you, and if you want, I'm gonna give you the times domain equation of this it's gonna be E of T, and we know that VR it's gonna be I1 T times R1. Since we're working with loop 1, so everything here that you see inside here, it's I1, and once this side is IC, and then this side is I2. So that's what you see there. So I'm trying to give you an idea, but when you see loop 1, this is what you're gonna write there. So it's gonna be this equation here, plus VC, we know it's gonna be 1 over C integral from 0 to 1 I1 T dt, plus VL, and VL it's gonna be for VL it's gonna be something like it's gonna be L dt. Okay, and if you go this side, you need to know VR2. Okay, I'm going just to replace both inside this one. So it's gonna be something T R2 equal to 1 over C integral from 0 to 1 I C dt, the voltage across the capacitor. And then if you have to solve this equation, you're going to replace to solve the value and then replace into the current. Okay, so in that way you will be able to solve. Okay, so you're going just to take, you know already you got IC, so this is what you're gonna replace there into IC, and then also just to swap the value around and solve for the equation. Okay, now this is what I was trying to give you. So for the introduction, how you can go about solving this question. Okay, and yeah, so far.